In this segment, I'd like to describe the ontology, and we can see the ontology here. When we come to the screen, we see two large tables. The table on the left contains concepts in the ontology, and the table on the right contains target language words. Right now we happen to be linked to an English lexicon, so we see English words here. And we notice in this drop-down that the concepts have been divided into 7 different semantic categories. So for example, we have objects, which are the semantic equivalents of nouns, events, which are the semantic equivalents of verbs, object attributes, which are the semantic equivalents of adjectives, event attributes, which are adverbs, relations, which in English are realized with prepositions, conjunctions, and particles. And let's take a look at some of the events. One of the first things we notice here is that there are various colors over here, and these colors are explained in the setup dialog. We've adopted some of the foundational principles of natural semantic metalanguage theory, as developed by Anna Wierzbicka, Cliff Goddard, and others, and they've proposed that there's a small set of innate concepts that are present in every language, and every word in every language can be explicated or defined using these innate concepts. And they call these innate concepts semantic primitives. So semantic primitives are indicated with a blue cell. For example, B sense E, the existential sense, is a semantic primitive. It's present in every language. Now we can't develop the semantic representations using just the semantic primitives. That would be unwieldy, the text would be drawn out, and the message wouldn't be communicated faithfully. So we've also adopted what the NSM theorists call semantic molecules. The semantic molecules are semantically more complex than the primitives, but they're still semantically simple. And for this project, we've adopted the defining vocabulary in Longman's Contemporary English Dictionary as our set of semantic molecules. So the semantic molecules are indicated with the yellow cell. So most of these concepts here are semantic molecules. Next, we have complex concepts that have insertion rules. For example, betray, sensei. These concepts are semantically complex. They don't appear directly in the semantic representations, but if a target language has a lexical equivalent for any of these concepts, the linguist can activate the associated complex concept insertion rule, which I'll describe later. And then, after that rule has been activated, concepts such as betray will be automatically inserted into the semantic representations. Next, we have complex concepts that don't have insertion rules. For example, baptize and beg. We're working on building complex concept insertion rules for all of these complex concepts, but we're not there yet. Eventually, this category will be empty. And then we have inexplicable concepts. They're indicated with a brown cell. For example, names, proper names and numbers, concepts like those are inexplicable. Then finally, linguists can enter their own concepts into the ontology. Those concepts won't have a semantic complexity level, but they'll be indicated with the red cell. And while we're here looking at this dialog, I'd like to mention a few other things. For example, you can change the colors of any of these tables or cells by clicking on the cell and then selecting a color like that. I don't want to change the color, so I'm going to say cancel. But you can set any of these colors that you want. You can set the color of the target table if you'd like. While we're here, you can also set the height of the grid rows, making them larger or smaller. You can also set the height of the edit windows, etc. Let's go look at some of the objects. Okay, here we see a number of the cells in brown, which I mentioned. These are inexplicable concepts. These are all the proper names. Now sometimes it's convenient to look at a small subset of the concepts. Suppose, for example, one morning you're working in Daniel chapter 1, and you want to see just the concepts in Daniel chapter 1. So you can specify that. Now here are the objects that are in Daniel chapter 1. And sometimes it's convenient to look at some of the semantic subsets, for example, masculine names, feminine names, geographical names, etc. So here are the masculine, feminine, and geographical names that occur in Daniel chapter 1. And sometimes you'd like to export those concepts, the subset of concepts, to a text file. for example, nouns in Daniel chapter 1. Now that set of concepts will be exported to that text file, and you can give that text file to your mother tongue translator or anyone you'd like. When you want to remove the subset restrictions, leave all the boxes unchecked, and then go back here and select the entire ontology. So now we're looking at all of the concepts again. I'd like to go back to the verbs for a minute, go back to the events. Every event has an associated theta grid, and if you rest your cursor on this column, the pop-up will show you the theta grid for that particular event. So for example, the B sense E, which is the existential sense, always has an obligatory agent NP. And if you right-click, there's a pop-up menu, and the second entry is particularly useful. This will show you all of the occurrences of that particular concept in the semantic representations. And you can right-click on any of these. Let's click on this one. There are many soldiers and many officials in your army. Let's go back up here. If we right-click there, then God said, "Let there be light." Then there was light. So that's the existential sense of B. So you can right-click on any of these and see all the occurrences of any particular concept. Sometimes you want to enter target language words at this screen. For example, let's go back to the objects. We notice that, for example, 5 p.m. isn't yet linked to a target language equivalent. So we can say new target stem, and let's enter 5 p.m. Now that target language word will be entered into the lexicon and will be prompted to set the various features. 5 p.m. is common, it's not proper, it's neuter, etc. We won't go into all the detail here. We would never have 5 p.m. pluralized, but we'll leave that. Okay. Enter a gloss. And now we can link 5 p.m. by clicking on its cell. You'll notice that the mapping cell goes black. Now we can click over here on 5 p.m., the target language equivalent, and you'll see that 5 p.m. is entered into row 1350, and now 1350 appears in the mapping cell. Click on that again, and now the concept 5 p.m. has been linked to the target language equivalent. And if you rest your cursor there, the pop-up shows you that it's 5 p.m. And that will conclude this particular